Hello all, welcome to another video of Data Science with Julia. In this video, we are going to look at sigmoid function. So what is sigmoid function? So let me just show it to you in Wikipedia. So this is it. So if you look at sigmoid function, like no matter whatever value you give it in y-axis, the x will be like between like 0 and 1. So you can just squash it. Okay, so that is the significance of sigmoid function. So that's the thing. And it has been given by this equation, like s of x is equal to 1 by 1 plus e power minus x. So that's the thing. And why are we going to use it? Okay, so okay, just imagine like okay, like if 0.5 means okay, nothing's been decided, and above zero point 0.5 means okay, like it's true, and below zero point 0.5 means it's false. So if we can assume something like that, then we can classify stuff depending on numerical values. Okay, so that's the thing. Like, so you have, okay, let's say like you just have some weights over here. So weights of animals. So people are collecting weights of animals and so on and so on. I don't know how much animals weigh, but yeah, so that's the thing. But yeah, people are collecting weights of animal, and you just have something like 350 kg, and people say it's a pig and something like that, or like 200 kg, it's a pig, and what to say, another 300 kg or something like that, and they still say it's a pig, and 380 kg, they still say it's a pig. And then something comes along with 400, 420 kg and say it's a baby elephant. Okay. And so, yeah, beyond 400, it continues as baby elephant. So, this is a numerical value. So like the weights is numerical value, but you need to squash it between like 0 and 1, and what to say, and make a point, and you should be able to cut off at 0.5 and say that things above zero point 0.5 are 1 and things below zero point 0.5 are another thing. That is, things below zero point 0.5 are possibly pig, and things above what to say, zero point 0.5 are what to say, um, baby elephant. Okay, so things below are pigs, and things above are baby elephant. So how do you do that? So okay, so you have sigmoid function. So the thing is like taking the sigmoid and just putting it on top of this graph. So you will actually put like this. Okay, so actually what to say is like okay, you just have this graph. So imagine like this sigmoid is stationary, but yeah, relatively this graph is moving. So you'll just move the sigmoid and make it just somewhat like this, slightly before 400, this zero point 0.5 will cross. Okay, so and that's how you'll just make it. So this is how mathematically you'll do, and this is what we are going to do. Okay, so look, this is not building our machine learning algorithm. This is about like learning how sigmoid can be used to classify from numerical data. Of course, it is part of machine learning, but yeah, like I just want you people to know about sigmoid. And compared to other data science videos, okay, what I want is like I want people to be really good at math. Okay, so I want to explain math in terms of data science and data science in terms of math. Okay, as easy as possible, hopefully. Yeah. So yeah, that's how it is. So if you look over here, so at 400, you can see the dotted line over here. So this dotted line just slightly above this, slightly beyond this 0.5. So it meets at 0.5, some little bit thing higher or something like that. Okay. And yeah, so that's how it is. I will come to this, what to say, page later. Okay, so yeah, all these diagrams and all will be available to you. Don't worry, right? So that's the thing. So how are we doing it? Let's look at our Jupyter notebooks. Okay, so first I have defined a function called sigmoid of z. I'm just using z for because like x, y, I just want to use it for graphs. Okay, so that's the thing, right? So sigmoid of z is equal to 1 by 1 plus what to say, e power minus z. So exp means exponent, that is e power. So if you can take a look at this one, yeah, this is I just wrote this equation. The s of x is equal to this one, right? So this first thing I just wrote, okay, this one, right? So that's how. So very well. And then Yeah. So, and now what I'm just doing is like, okay, now I just have like x is equal to minus 10 to plus 10 in steps of 0.01. Okay, so that's what I've just taken. And what I'm just doing is like I'm just doing element wise sigmoid. Okay, so this feature is there in Julia. Like you can just write a function, easily convert it into an array operation, right? So that we can just do. And now I'm just using plots and I'm just plotting, and you just get a wonderful sigmoid over here. So you are just having a wonderful sigmoid, and at 0 it just crosses 0.5 and all those stuff. So now I'm just doing is like I'm just taking away minus 399 from x. So this dot minus is nothing but like what to say, like element wise subtraction. So x is, think x as a vector or array, right? Actually it's a range, but you can think like that. Mentally you can think like that. I think like finally the range gets converted into a vector, and only after that these operations take place. Okay, so I'm just minusing 399 or something like that, and then I'm just plotting sigmoid. Okay, plot. So x is there, and y is sigmoid of x minus 399, and I'm just plotting it. So if you just look, okay, so at 400, it's almost kind of greater than 0.5, and it just goes, right? So yeah, there might be slight error, but yeah, machine learning is not about very accurate. I don't think even Tesla cars or whatever very accurate machine learning driving algorithm drives millimeter or what to say sub millimeter accuracy. Okay, so it's okay, like you get it up to some what to say thing. Okay, so now we are just writing a function, right? So classify animal, and in this, yeah, we are just only getting one weight. Okay, so this graphs and all is for right now, it's for human to understand. That is for us to understand. We are visual animals, so I don't think we have reached an age where we can give graph to computers and tell it to make it understand. I don't know. Maybe yeah, some there might be some fringe research that has done that, and maybe yeah, it would have already happened. Who knows? Like AI is just going like hell. Okay, like it's expanding like hell, and its domain is reaching like hell. I think it's going to be like electricity. Already, yeah, like everybody uses Google. Everybody, almost everyone who uses electricity kind of uses Google, right? Most of them. Okay, so who knows? Like, and Google uses AI. So or any search engine, like people, almost every person in this planet is using AI or some kind of computing. Okay, so that's the thing. Okay, so I'm just minusing 399. It's just element wise minus, and that's how it is. Okay, and yeah, you just got this one where it's slightly above 400. Okay, slightly before 400, it's 0.5. So it's hard to view. Okay, in this scale. Okay, so I'm just putting this equation over here. So weight minus 399. If the value is greater than 0.5, print baby elephant, or else print pig. Okay, so that's the thing. So that's the thing. Okay, so what you can imagine is like, okay, you know, equation of a line is mx plus 6. So you can have something like m is equal to 1 and c is equal to minus 399, and you can just put something like this, and you still get this very same plot like this one. Okay, so this is nothing but like guessing a line. Okay, so I think like in this thing, like curve fitting with genetic algorithm, right? We have guessed the line. Okay, like where is it? Right. Yeah. If you see, we are able to fit a line to some points using genetic algorithm. So using sigmoid, you can use many things. Like, okay, one thing you can use genetic algorithms, and I'll also be explaining a thing called gradient descent. Okay, very soon. So like hopefully very soon, if I have time and if I have the mood and all those stuff. Or you can use gradient descent to determine it and all those stuff. Yeah, with gradient descent also, I'll be guessing a number and all those things, fitting a line and all those things. Almost the same thing can happen with genetic algorithm and gradient descent. They just work in two different ways, but they achieve the same goal, right? So yeah, so we can just guess this M and C with what to say, gradient descent or genetic algorithms. Okay, so this is the thing. Okay, so if you can imagine this as a line, in fact, this is a line, like what to say, like x is equal to 400 is a line. Okay, so That's the thing. Like no matter whatever the value of y is, x is equal to 400, right? So that's the thing, right? And similarly, what you can think is like, okay, y is equal to mxc is a line. So you can classify it even in 2D space. Over here, we are only having just 1D, like weight, okay? So in fact, like you can write even this function like this one. In fact, you can write this function like, okay, like, let me just make it small. You can write this, okay, not over here. Here, so classify animal 2, since it's just, what to say, it's just, if you just consider a bunch of points, what you can just do is, you can just write a function like this. If value is greater than or equal to almost like 400, yeah. Yeah, you can't say about 400, right? It's a boundary condition, right? So this is the thing, and okay, now, okay, classify animal 2, classify animal 2, if I just put it like 300, it'll say, okay, wait. Okay, so, okay, so it'll just say pig, and if I just put like 450, it says, anyway, it has been quite a while since I ate pork. The reason is I live in very conservative India where pork is very tough to get. Okay, so that's the thing, and yeah, that's how it is. Yeah, so yeah, like yeah, it just, in fact, if you just consider this one, if you just ignore this line and if you just consider this line like only x, you can write a function. But if you are considering this line, you can like you're adding some kind of additional dimensionality, and you are going with something like this one, like y is equal to mx plus c or something like this one, right? So that's how it is, right? So similarly, you can, okay, like, yeah, this is just using one dimension, you're just drawing a line in between. And of course, a line can be drawn between a two-dimensional stuff also. Okay, so that's the thing. So y is equal to mx plus c. So theoretically, you should also be able to solve this, like some value in the y-axis and some value in the x-axis. Depending on that, we are classifying stuff, and then this should also be should work. So possibly in future I'll be putting videos for this one, right? When I get the time and I get the mood and all those stuff, right? And yeah, so that's how it is. And you can even extend it further. Like, okay, so what is the equation of plane? Like, okay, so what to say? Like, plane is nothing but z is equal to ax plus by plus c, right? So okay, yeah, this is the equation of plane. Okay, so and yeah, so you can just make it like z is equal to, okay, ax plus by d whole divided by c. Okay, so you can also classify it like a plane, and so even if there are 3 dimensions, it will work. And even with 10 dimensions, then it's called a hyperplane. Okay, if more than 3 dimensions, it's called a hyperplane. We can't visualize it. Maybe if you can visualize it, or if you're able to sense it, how it will work, yeah, it's really great. Then you're possibly even greater than Einstein. Okay, so like, yeah, it's called as hyperplane. With 10 dimensions also we can do, and not at all a problem, right? So that's how it is. And so yeah. So yeah, this is a sigmoid function, and we can classify things, and that's how sigmoid function is being used. Like, you can squash anything between 0 to 1, and anything below 0.5 is, you can say no, or anything above 0.5 you can say yes, or you can also say it in the reverse way. Anything above 0.5 is no, and anything below 0.5 is yes. So it all depends on you, but the thing is, like, you're just squashing it into two binary values. It's for that sigmoid is very, very useful, right? So that's the thing. I hope you people understood it. I hope you, okay, could appreciate the power of sigmoid, right? Squashing of values and all those stuff. But yeah, even if not, yeah, don't worry. Yeah, I'll be writing it in code and doing it. Possibly you might get it at that time. So just shrug off, chill out, and possibly you'll be able to understand in the future. Yeah, that's how even it happens to me. Like, I just chill out and I just get it, like, this vision out of nowhere. Okay, so that's how it is. If I can do it, yeah, you people can do it. So this is the thing. Yeah, anyway, thanks for watching the video. So I'll be putting all these links, and yeah, let's catch up in next video. Bye bye.